this picture is like before I got old. So yeah, before tenure, you look young, and then you get very stressed. All right, so I'm really delighted to be here. It's the first time I'm talking to like 1,000 people, so I'm a bit nervous. So hopefully you don't mind my nerves. What I want to do is walk you through, for the first 45 minutes or so, some of the insights that Marco and I have been developing really for the past 7 years at HBS. So 7 years ago, we started this course on digital innovation and transformation. Digit is still in the EC. And we were both sort of studying the software sector in different ways. And as we were trying to think about what was happening in the broader economy, the market structure, the operations, the strategies that we saw emerge in the software industry in the 90s and the 2000s was spilling over into a whole range of industries. And that became that started our journey to really think about why is it that all industries were looking similar and why were there such similar dynamics going on. And hence this deck and these insights that we have generated. And really it was the casework that we did, talking to a whole bunch of companies that got us to sort of develop these insights together. There's a ton of hype around AI. It's probably the most buzziest term around. If you don't attach AI to your company name or to your CV, it's not going to be great, right? And so this is everywhere. I'm Canadian, so Canada believes it can lead a global AI innovation. It's awesome. Toronto has become the hub for AI in many ways. Not the Raptors, though, because I'm a C's fan. A 19-year-old developed code for the AI portrait, Americas. But you can see this, right? There's a ton of headlines around AI that are emerging. And this is not just a theoretical thing, even for Harvard, right? So our cousins down the street, MIT is investing $1 billion, right, in creating a new college of computing, thanks to a big donation from one of our alums, one of you guys. So, it's like, wow, right? So this is like, Nitin is thinking about this, Larry's thinking about this, Alan is thinking about this. Everybody's like, wow, what's going on? And by the way, this is actually amazing news for all of us, right? So if MIT is going to create the supply of the technologists, right, those ideas, those skills still need to be converted into businesses. And who best to do that than here, right? So I actually see this as a major feature and not a bug, right? That if we can understand how to deploy AI, right, then there's going to be tons of opportunities for all of us here as well. So I think this is a really good thing for us and not a bad thing for us. We still need to raise $1 billion, but that's a different story. So, of course, again, around this hype, startups in AI, lots of the number of companies that are, it was like what happened a few years ago with blockchain. If you had a blockchain to your company's name, you had a big boost in investment. Same thing's happening with AI now, too. Lots of companies are emerging. And whenever you see an increase in volume of activity, like lots of entry going on, you should be thinking about two things. One, people are seeing opportunity. Right? People are seeing opportunity, lots of opportunities emerging. At the same time, probably the cost of entry is also dropped, right? When you see a big boom like this, people see gold, and I can get to the gold, right? And that's why we're seeing this happen in the economy as well. But to ground this and to sort of get us to start thinking about this in a broader way, I want us to take us out of the world of business and go to the world of art. All right. Anybody take art history as a major? Any guesses on who this painter was for this? Rembrandt. Yeah, you guys are smart. Yeah. So this is known as the next Rembrandt, which got created a few years ago. I'm going to show you a quick video about this, just so you can see the same principles that go behind creating the Rembrandt are also what is powering this big revolution for us as well.
One of Rembrandt's great achievements was to portray human emotions in a much more convincing way than artists had before him. And in many ways for all time.
At ING, we believe in the power of innovation, what it can mean to people. We want to bring this innovative spirit to our sponsorship of Dutch art and culture. We knew that for this challenge, we needed to team up with experts from various fields to make this come to life.
We're using a lot of data to improve business life. But we haven't been using data that much in a way that touches the human soul. You could say that we use technology and data like Rembrandt used his paints and his brushes to create something new.
The first step was to study the works of Rembrandt in order to create an extensive database. We gathered the data from his collection of paintings from many different sources, including 3D scans and upscale images using a deep learning algorithm. Because a significant percentage of Rembrandt paintings were portraits, we analyzed the demography of the faces in these paintings, looking at factors like gender, age, and head direction. The data led us to the conclusion that the subject should be a portrait of a Caucasian male with facial hair between 30 and 40 years old, in dark clothing with a collar, wearing a hat, and facing to the right. From there, we started to extract features only with faces that were related to that specific profile.
And we had to create a whole painting from just data. And we used statistical analysis and various algorithms to extract the features that make Rembrandt Rembrandt.
We took parts of the face and we started to compare them. And then, based on this, we're able to create a typical Rembrandt eye or nose or mouth or ear. After generating the features, we were focusing on the face proportions. We used an algorithm that can detect over 60 points in a painting. We were able to align the faces and to estimate the distance between the eyes, the nose, and the mouth and the ears.
A painting is not a 2D picture. It's 3D. You can see the canvas, you can see the process, and that's what makes the painting come alive. A hive map is essential to make the painting a painting.
We incorporated the height map into the painting and printed on a 3D printer that uses a special paint-based UV ink. It printed many layers, one on top of the other, which resulted in the height and texture of the final painting.
It's sometimes a magical moment to see a painting for the first time. Even if it's computer generated, for me it is something special. I would have believed if I saw it in a museum that it would have been a real Rembrandt, just one I haven't seen before.
It will be interesting to see Rembrandt looking at it. He will be happy that there are people trying to understand him and trying to create something out of that. So I think he will be happy.
The next Rembrandt makes you think about where innovation can take us. What's next?
So what's amazing about this picture to me was I was at an exec ed session in our school, and unbeknownst to me, in the audience was the head curator for the National Portrait Gallery in Australia. And he was a Rembrandt expert. So I first showed this photo, and he goes, oh, that's a Rembrandt, and all the things they said, he said. And so for him, and I just have never seen this one before. So it might be a really good forgery. But what it showed was the fact that just simple data can help you think about the problem in a very different way. And non-experts in art, right, the guys who you saw talking had no expertise in art, could then generate something that looks like a Rembrandt. Now, of course, this is both celebrated, right? But also hated, right? And so these dual reactions are going to be what many of us will be facing as we think about the deployment of a digitized operation in our companies that's going to be powered by AI. Right? On the one hand, we'll be like, this is amazing, I love what this is doing. On the other hand, oh my God, what about us humans? Right? And I think that's going to be the debate, central debate that you all will be facing as you enter back into the workforce and start thinking about these ideas and their deployment. So one more foray into the art world. This picture is the first ever picture, digital picture taken by Russell Kirsch in 1957. And it was the first digital image, 176 by 176 pixel. Of course, now your iPhone has orders of magnitude more pixels than what this was. This cute baby is Walden Kirsch. So this is the part where we need to sort of understand the basics of what it means for us to digitize the operations. When we digitize something, what happens is that we can take this and infinitely replicate this at zero marginal cost. Right? So this picture, right, in 57, maybe taken in Boston, right, is instantly replicable in Bombay, right, and in Brisbane and Beijing with zero marginal cost. So the zero marginal cost story is part of why digital operating models are so scalable. Okay? The second thing is, today, with some fancy deep learning, convolutional neural nets, and all that kind of fancy jargon, we can take baby Walden and try to make it better, right? And then we can also, maybe even age it a bit. So you have an old-looking baby Walden, right? You've all done the Facebook. You gave your face to the Russians, and they aged your face. You did that all, right? Something like this was going on, right? The Russians now have your photos, by the way. Somewhere in Moscow or Belarus. So again, digital, the data can be used to distribute widely, but also I can then apply algos and make it better. And part of what we're sort of seeing in front of us is that digitization has been transforming our economy. And what I want you to take away from this slide is the notion that what's happened is that at each architecture point in the tech industry, each technological architecture in the tech industry, there's also been an economic architecture that has also changed as well. So in mainframes and corporate networks, we were all thinking about product-based companies, right? Selling the magnesium grade casings and the fancy lights, right? Then in the PC and web era, networks start to explode, and the start of platforms and ecosystems come through where companies competed not just on what they could do, but what their ecosystem could do as well. Then in the era of cloud and mobile with Google and Facebook, what happened is they said, oh, not only do we compete with the platform and ecosystem, we can now change the value creation and value capture logics that we have going on. I can give a lot of products for free, I get the audience, and then I monetize that with somebody else, right? So the architecture of the technology changes, so does the economic architecture also changes as well. And today, in the world of networks and AI, we're sort of in this AI-first world, right, where all these industries are converging through these giant hubs of Alibaba, Google, Facebook, Amazon. And we're now thinking about the rise of these large hubs emerge, where lots of companies now need to attach through them to access the rest of the world. So this is going on. And this, by the way, changes the market dynamics a bit as well. So I don't love this metric. It's like the market capitalization per employee, but it's a metric that we can all sort of agree upon that it has some meaning. And when you look at a Walmart versus a Ford versus a Verizon versus Qualcomm versus Goldman Sachs versus Ant Financial or Facebook, you see dramatic differences, right? So like Ford is working pretty hard, right? Their factories are buzzing, right? They make billion-dollar bets on their factories on the next Ford truck, but the market is remorseless. Thanks for working hard, guys. I'm going to go to Ant Financial instead, right? And so this is like the economic reality that we're faced with, and we'll have to sort of grapple with ourselves. And the point here is that, by the way, Ford also needs the workers that are at Facebook and Ant Financial, and so does Walmart, right? And so that becomes a big challenge going forward for us. So I want to spend a few minutes talking about Ant Financial. Those of you that have been to China or are from China know how powerful a company this has become. Ant Financial comes off as a spin-out of Alibaba. Alibaba was trying to basically do e-commerce in China. The payments infrastructure wasn't that great, right? There was no credit cards, no credit ratings, that kind of stuff. So they set up Alipay as an escrow system, right, to simply allow payment transparency and payment trust amongst merchants and buyers. Alipay sort of moved along for a while, and then in 2013 and 14, you get to see this linear, this super linear scaling of their user base. This is directly correlated with smartphone penetration in China as well. Okay? So, but Alipay becomes part of Ant Financial. Ant Financial doesn't just stop at transactions and at escrow, but offers credit, banking, financial cloud services, investment services, you name it, right? By the way, the scale here is that at the time there's a case on this company, they had about 750 million users, and that was powered by 10,000 employees. So 10,000 employees, half technologists powering 750 million users, right? And about $1 trillion in transactions, okay? So they're global, they're worth more than Goldman Sachs, okay? You know, they're approaching valuations around Bank of America, but Bank of America serves 40 million customers, versus they are now approaching 1.2 billion customers, right? So again, a new type of firm is emerging. Again, just think about those that have been on the guts of a bank or of a large-scale company. How do you serve 1.2 billion customers, right? That's a big number. And Ant is a weird company. It's like if you look at their app, like, okay, there's like payment and scanning and Pocket, but they're also like air and rail tickets. I can get city services. I can go to Taobao and purchase. I can do family. I can do donations. I can do all these different things. So this notion that I'm not just doing payments, but I'm expanding into your financial life is part of the story that we see emerge along these giants. And that they're trying to basically, anytime you need money, they're there, one way or the other, and they participate. And so the concepts of a multi-sided platform have been discussed in Tom RC, of course, right? And so they try to connect different types of platform participants in their network. And we know that multi-sided platforms exhibit network effects. And network effects are simply that the value of the product or service you're using increases as the number of users increases, right? Most products and services that we have a fixed value. Like this remote control has a fixed value. Even if all of us had this remote control, the value of this would be the same, right? What a network effect says that, no, the value of the product or service will actually increase as the number of users increases. So that's one big thing around this. And this, by the way, of course, is the same thing that happens with all the other companies as well, right? They are all based on trying to build network effects in their core business. Secondly, you can't have human beings at the center of this organization, right? It has to be robots. It has to be machines. There's no way, right, some human being is going to make a decision on credit for a person at this scale, right? There's no way some human being is going to make a decision about fraud or not fraud in this system, right? Humans will be in the loop somewhere, right, but not at the core. And the whole idea here is that we have to use AI to basically operationalize our bottlenecks. Remember bottlenecks? Is that going to be in the exam? Okay. He's not saying anything. I have no idea. You know, and so that becomes part of what allows them to scale in this way. So let's just get our definitions right. What is AI? So this is the theory and development of computer systems able to perform tasks normally requiring human intelligence, such as visual perception, speech recognition, decision making, and translation between languages. And there are many. There's lots of drivers for AI. First is that more and more data is being generated, right? Everything we do now is datafied. Any activity you're doing is being datafied. Right now, Google and Facebook and Amazon and Instagram and Snap, they all know you're here at this location. Right? You're broadcasting your location to these platforms. There's lots of computing available that allows us to analyze this data, and there have also been great advances in algorithms. So we should just get clear about the definition of AI. The first definition of AI, which I love, machines that can think and act in a way that it matches or surpasses human intelligence, is known as strong AI. This is the AI of science fiction, of Star Trek, right? And this is where we get scared. We go, oh my God, like strong AI is going to come and robots are going to take over the world. Another definition is weak AI, any activity computers are able to perform that humans once performed. Right? That's weak AI. And what our thinking is, what Marco and I are thinking, is that this actually is what you need to get the ball going. Right? Google and Facebook or all the multi-user AI startups don't have strong AI. They take 1 or 2 or 3 or 100 activities, right, and say, can I do it better with the algorithms? Right? Can this become better or not? And just deploy that. And there's lots of use cases of weak AI replacing or augmenting humans. Let's take this Uber Eats example one step further. So the data, right? What's going on with Ant, right? What's Ant doing? Ant's taking the data they have from one set of transactions and saying, I can now spin up and go to the next set of transactions, right? They're expanding scope, right? Scope expansion is part of what we see many of these companies do, right? And in many ways, this runs counter to the advice that American management gurus gave in the 70s and 80s and 90s. Tom Peters, right? In Search of Excellence, stick to your knitting, right? Do one thing really well. You need to do that for sure, but these guys are saying, let's actually think about scope expansion because we have the data, and that data allows us to cut across a range of markets. The other thing is that they also use the data to drive digital learning. The whole setup within a platform is, as you get more data, you build better algorithms. As you get better algorithms, you get better service. As you get better service, you get better usage. You get more data, right? And this flywheel turns, right? And that's why the data side is so important as much as the algorithmic side. And what we are sort of talking about is that now many companies will need an AI factory inside of their operations. Okay? This is not like Donner, thankfully. And this factory, by the way, is going to be the same regardless of the company you're running. So the McDonald's AI factory will look the same as the Ford AI factory. Right? A hamburger factory in reality is very different from a car factory, but the AI factory is going to be the same. And the elements here include a data pipeline, algorithmic development, infrastructure development, an experimentation platform, and your ability to productize and deploy. Right? This becomes the core aspect of the operations that many companies will now be striving towards for. So let me give you an example from China again. Pig farming in China. This is a great, awesome example about how you get data. So JD Digits, it's a stepchild of JD.com, trying to do in finance. China is the largest pork producer and consumer, occupying 56% of the total production in the world. Market size close to $200 billion US dollars per year. But more than half of China's nearly 700 million pigs are raised on small-scale farms, family farms with less than 500 pigs. And the Chinese government is encouraging these large companies to provide financial security. So JD Digits thought, oh, fine, let's offer insurance on the health of these pigs, right? So the problem, though, is this is going to be ripe for fraud, right? Because how do I know which pig got sick? It's a real problem, right? Like if you're going to build an insurance product around insuring livestock, you must be able to identify them one way or the other in an easy way, unless you sort of did a DNA test and sent it to the lab and that kind of stuff. It's going to be very difficult. So these guys came up with pig facial recognition. Let's datafy the farm. Let's datafy the farm, right? And then use that as a way to build a financial services product, right, that I can go to market with. So let's have a look at this, right? So there's lack of labeled pig face data, right? Similar to what Avery was saying, that there's lack of labeled data around the medical records. So they basically went to some farms, put some cameras on, and started to build an algorithm for pig facial recognition, okay? And CNN is a convolutional neural net that allows you to sort of do that, right? And so this allows them to now start to create products in interesting ways for the farmer. So not only are they doing this and have an insurance product, they can then also say, hey, I've got this digital infrastructure now in the farm. I can now give you a weight estimation. I can give you how healthy the pig is. I can tell you how you should feed them, and so on and so forth, right? Think again, scope expansion. I can now be in the supply business for farmers because I know what's happening with your livestock, right? And now you might be wondering, well, how will they know in a moving farm what to do? Well, they also have a solution for that too. So they have got tools to count pigs, right? And know which pig is which and what they're eating and what they're not eating along the way, right? This is datafication, right? The data pipeline story happening within a farm setting. And then using that data, not to sell the technology to the farmer, but actually to create services on top, financial product services on top of that, right? So datafication becomes a key element to think about. The second thing is, we talked about algorithmic development. What's nice is that much of the algorithms are available off the shelf. So the cloud providers like Google, like Amazon, like Microsoft have made these solutions available for you as plug and play. Again, you still need a data science expertise. You still need to be able to connect them together. But no longer are we spending $40, $50, $60 million, right, trying to create the algorithms. Those can be gotten off the shelf. And the Zebra imaging case gave you a hint of that, right? They were spending a lot of money on algo development, and then they shifted over to TensorFlow from Google, right? So this is now becoming off the shelf. And it's so off the shelf in some ways that even a faculty member at Harvard Business School can now write papers about AI in cancer detection and lung cancer segmentation and get published in the top oncology journal, right? So this is me. The last time I took biology was in the 10th grade, and I got a C. Now I'm publishing in a top life sciences journal because we were able very cheaply using crowdsourcing to generate these algorithms and actually now be as good as the average radiation oncologist at Harvard Medical School, okay? We spent 80 grand and 8 weeks in prize money to get this done, right? So again, what I want to tell you is that these tools are becoming widely available and are relatively cheap. Okay? So let's think about what an AI factory looks like. This is one AI factory at a company called Ocado out of the UK. They are building warehouse automation for food for grocery stores, right? And this is a fully automated warehouse. These robots go on their own, do their own thing, right? Pack, pick, deliver, make it all happen. Ocado now has the ability to give you the provenance of your cheese that you got from the farmer in the Midlands, that level of detail. And they are now, given all the data, they can now predict what you will want to order basically 4 days ahead. So they can actually be ready and packed even before you put the order in, because they have all the data that you have, right? After a while, once you get enough data about your shopping habits, we're pretty predictable people in terms of what we want to get from our grocery stores. So here's an example of a working, so the back end of an AI factory, okay? The same approach that Sam had put into place for her ad product is also running behind here as well, okay? And then here's the AI factory from Amazon.
4 years ago, we started to wonder, what would shopping look like if you could walk into a store, grab what you want, and just go? What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store so you never have to wait in line? No lines, no checkouts, no registers. Welcome to Amazon Go. Use the Amazon Go app to enter. Then put away your phone and start shopping. It's really that simple. Take whatever you like. Anything you pick up is automatically added to your virtual cart. If you change your mind about that cupcake, just put it back. Our technology will update your virtual cart automatically. So, how does it work? We used computer vision, deep learning algorithms, and sensor fusion, much like you'd find in self-driving cars. We call it Just Walk Out technology. Once you've got everything you want, you can just go. When you leave, our Just Walk Out technology adds up your virtual cart and charges your Amazon account. Your receipt is sent straight to the app, and you can keep going.
So again, the AI factory, okay? That's going to be a core component of a digital operating model. So we've talked about in the course here about business models and operating models. Business models are how about you create value, and how you capture value. In a world of platforms, you also have to think about value sharing. But then the operating model is about how you achieve scale, scope, and learning. And so if we go back to why this is so different now, right? Scale, scope, and learning has always been around, right? The scale and scope, a book called Scale and Scope by Al Chandler won a Pulitzer Prize. Al Chandler was a faculty member here at HBS. So scale is about how you just get more and more customers, how you serve more and more customers efficiently. Ford taught us that, right? Scope, have more variety, right? Sears taught us that, right? Before Amazon, right? And Toyota, TPS, right, taught us about learning and continual improvement. These images of these companies, by the way, don't look that different today, right? They all look about the same now, okay? And what happens inside of these companies is that in order for us to achieve scale, scope, and learning, we become into silos. We set ourselves up into silos where the IT group talks to one product team and only one product team, and that's all they work on, right? And same thing across the way. So the data that we have is widely fragmented and not available for us to drive the insights that we're talking about here. We were chatting with the CIO of Goldman Sachs, and he said there are 30,000 employees at Goldman Sachs, and there's 95,000 databases, right? Why? Well, it was very efficient, right? At Goldman Sachs, you're just out there to go get that deal done, right? Figure out that business line and make it happen, and don't be constrained. And that works really well in that world model, right? But in a model where the data is important, data of all consumers at all times is more important, we have to rethink how we organize ourselves. So what happens in this traditional operating model is that the value of the firm is constrained because over time, as the number of people we serve, the demands that we face in terms of complexity, cost, organization inertia, basically plateau out the value that we generate. Right? That's the reality that many of us face in large organizations. Getting anything done is difficult, right? It takes a lot of time, right? If I want to get data from one setting to the other setting, it's very difficult. I face this here at HBS, right? We have an MBA product. We have an exec ed product. We have an online product. We have an ER product. We have a publishing product. And there are 9 different IT shops within HBS. And they don't share data. So if you are also reading HBR, I have no clue what articles you're reading, even though they probably have that data available to them, right? Or if somebody goes to exec ed after 5 years at HBS, right, we won't be able to track that, oh, they're actually, what classes they take, what professors they saw, and so on and so forth. Normal things that you'd expect, we also face a problem here as well. And so digital operating models have these zero marginal costs and can generate both these network effects, but also learning effects. Because what happens is we get increasing value as our platform grows. We get more and more data. AI comes in and basically sharpens this curve for us. And so the traditional operating model performance drivers are such that we have to sort of think about scale, scope, and learning. But in a world where we have digital operating models, we now think about scale in terms of zero marginal costs. We think about scope in terms of aggregation and modularity across networks, and learning in terms of constant innovation and AI and ML. And so what happens, right? This is a traditional product business, right? This is now faced with the collision from the digital business, right? You have a decreasing returns business with an increasing returns business colliding, and this collision happens. And we see this collision happen over and over again. Nokia versus Apple. Marriott versus Airbnb. Ford versus Waymo. HSBC versus Ant Financial, right? And by the way, this debate is live at HBS, right? We have the MBA product, but in order for us to double the capacity of the MBA product, we'll need to build 2 Klarmans. Take a long time, right? And more donations from people like you in like a few decades, right? We'll have to double our faculty size, right? And expand space, right? But if I go online, right, I can just scale in a massive way. And so this creates a real puzzle even at HBS, because the MBA product looks at the digital product and says, hey, what's going on, right? I've got way better value than you do. You're like a sink of money for us, right? At the moment, we are investing a ton in the digital product. And this is what Harvard has to figure out as well. We have a traditional product business, and we need to think about an online business as well, because our mission for our education is not just people here, but the whole world, right? And so this is creating a tension within even our school. I think we are in this transformation stage for the economy, and not just one sector. Like in the 90s, I got my master's in the 90s, and it was the tech sector that was transforming, right? And lots of the bubble was being set up for the internet at that time. And the bubble bursted, and then we came out of it stronger eventually. But now almost all sectors are facing the same types of transformation opportunities. And I think that's where you guys have greenfield available to you to go forward. So let's give the bigger picture and sort of set this in terms of new rules. Star Wars is coming, and so there's a question about, is it the Empire or the Rebel Alliance that's gonna win in the end? We'll figure it out. All right. The first is this should not be a surprise to you anymore. Digital technology is everywhere, right? It's being embedded into farms and into your back pockets. What's happening are that 3 specific laws are converging. Moore's law, which says I can get faster and faster computation at lower and lower costs. Metcalfe's law, which says connectivity and value increases as I build networks. And Barabashi's law, which says that when you go into a world of networks and platforms, hubs emerge. Hubs emerge, right, through a mechanism called preferential attachment, which drives the creation of these large organizations. So this is happening across the economy, and this has enormous implication for the ways in which we regulate, the ways in which we run companies. Not all companies will be platform companies, right? Most of us will be working in non-platform companies, and so we have to figure out how we compete and participate in their ecosystems, right? And that's going to be a key challenge that we face. Second is that there's turbulence, right? All of this constant improvement in digital technology drives a ton of uncertainty going through, and there's lots of examples of people feeling unmoored along the way. The third thing is universality, right? Just as I was discussing that the McDonald's AI factory is the same as the Ford AI factory, as the Amazon AI factory, means that we have to now be thinking about data and analytics as the core drivers of what the firm does. We'll be living in this world of digital collisions, right? And we have to sort of figure out how do we organize ourselves, and what skills do we build, and what skills of leadership that we have to go across these organizations. So in order for you to run a modern McDonald's, right, you might hire somebody from Ford, right, which would never have been the case beforehand because there was no universality of those verticals. But now we sort of see this universality emerge. The fourth element here is recombination. We're seeing companies and the boundaries of what companies are being redefined, right? There used to be a telco sector, right, and there used to be a banking sector, right? And there used to be a social media industry, right? They've all merged together, right? So this recombination, because of connectivity, again, opens up new opportunities, but also creates new challenges. We see these hubs emerge everywhere, and then how do we participate in these hubs becomes important. And then the most valuable public companies are basically the ones that are creating these hubs. I don't think in the long term we can sustain this inequality even in company profitability, right, or company valuations, right? And that'll be part of the challenge that we all face. This ethics story is very important. We need to engineer the ethics now. We have to think about ethics at scale, right? So we have human beings are biased. We're racist, we're sexist, we're this, we're that. That's just part of who we are. We're flawed creatures, right? In the analog world, you could basically have your bias limited. In a digital world, you can bias at scale. I can train on biased people, I can train on biased data, and then I can discriminate on a highly scalable way, right? And so these issues around selective amplification, bias, control, privacy, these are going to be top issues that business people will face, right? It's no longer a question that we're going to let our law school cousins deal with this, right? Or the Kennedy School cousins deal with this, because this will be a boardroom issue. Right? This will be a boardroom issue that you will all face as you design these systems going forward. So questions around cybersecurity, transparency, concentration, and so forth comes at it as well. So here's a call to action. You have to sort of understand and actively anticipate the transformation of our social and economic environment. We have to drive sort of this innovation and operating model transformation to create this foundation for change. We have to focus on our own digital business models and leverage these new digital opportunities for new revenue, collaborate to break up the competitive bottlenecks because they are going to be there, support a multi-platform economy, drive interoperability, multi-homing. Those are going to be key strategic but also technological issues that go hand in hand. Leverage partnerships, communities, and crowds to drive alternative platforms, and then also understand the regulatory options, right? The regulators are in business, right? In Europe, in China, in the US, and we have to figure this out. So a list for the readings. If you care about platforms, the first 3 books, Second Machine Age, Platform Revolution, Business of Platforms, recommend them highly to get into the economics of platforms. Ming Zhang's book on Alibaba, Smart Business, awesome book if you want to really understand the rise of Alibaba and financial. AI Superpowers, Political Economy View, China versus the US, again, a great book. I really love Prediction Machines. This is a book that really talks about the economics of AI and the economics of prediction as one part of AI. Marco and I have a book coming out, Competing in the Age of AI, in January. And then I also love science fiction. So William Gibson, Ian Banks, and Leckie, great science fiction writers who are thinking about machines and AIs and humans. William Gibson thinks maybe 30 years ahead. Ian Banks thinks centuries ahead. And Anne Leckie has this great ancillary justice series where the protagonist is the AI, right? The protagonist is the AI. So as a thanks to Elise and Sam and to Avery, we're going to give them a copy of the book now. Okay, so thank you very much. But all of you get a copy as well outside, all right? So we were able to, the book comes out on January 7th, but out in the hallway are the copies of the book. Thank you so much for taking the time. Thanks.
Thank you.